So today we're going to talk about queue data structure, and we have basic comparison with stack. And queue can be inserted at one end, and it can be deleted from other end. We'll see an example, and it will be more clear. For now, it's just a basic overview of queue, and it's a double-ended list. So now, what is a double-ended list? Basically, you can do operations from the start of your list as well as the end of your list. To both the ends, operations can be performed. Unless like a stack, where the operation can be done only at one end. That means the top of the stack. So basically you insert an element at the top of the stack as well as you delete an element from top of the stack. But whenever you come to queue, you can actually delete it or add elements from the one end of the list and delete an element from the other end of the list. So basically you can like do two operations and at both the end of the list. So that's why you call it a double-ended list. So let's see a very quick example so we can have a better understanding of this one. So for example, as the name suggests, queue, we're gonna really have a queue over here. And there are 4 people waiting to get some tickets. And what do you think about this when you see the diagram? Like when you see the situation over here. Who gets the first ticket? This person, or this person, or this person, or this person? And obviously it's going to be the first person that this person is going to get the ticket first. Okay? Because he's the one or she's the one who's first arrived to get the ticket. So this person is going to get the ticket first, and when they get the ticket, they just leave. So they're no longer in the queue anymore. I'm so sorry. Oh, sorry. Oh, God. That's my mistake. Okay. So they're no longer in the queue anymore. So now there are only 3 persons left. Now, who would leave the next? The next would be this person. So this person got their ticket and they leave. And this person got their ticket and they leave. And this person also got their ticket and they left. So, yeah. So this person entered first and they got the ticket and they left first. So this is what we call DQ or deletion. And first in, first out. Okay? This is a first in, first out. Not like stack where you do last in, first out. It's a first in, first out. It means you come in first and you leave first. And over here it would be last in and last out. If you come last, you are the one who leave last. Okay? And there are 2 ends you call a rear and a front. Okay? And this is the 2 end of the list. Imagine this is a list, and in this list, the rear is where you insert elements. I mean, where people keep on adding or insertion. Yeah, so what you would call this operation is insertion is NQ, and deletion is called DQ. So you delete from front and you insert. People start coming from the back, so you like insert from here. So this is how a normal queue works, right? So whenever you see a queue, this is how it works. So these are some functions that you will see. This is pretty much similar to the stack. Is full, is empty, and display. Only these 2 were different. And we'll start with the concept and implementations. Now these 2 points are really important you need to know. First thing is NQ. So whenever you're doing insertion, you need to make sure that you're inserting from the rear point. That means the back of the list or something. And whenever you're removing, you need to do it from the front. Okay, and that means you need to perform it from here. So whenever you're removing, all right. So let's get it started. So we're going to be doing a a queue implementation by using array. Now this is going to be a very simple version, and it's going to be like a very basic implementation, and I'm going to show you what we're going to do. Oh, sorry. So basically we're going to have an array, okay, and we're going to have two variables for the front and for the rear. And as I already mentioned, we would be using the front for the deletion and the rear for insertion. This is something to keep on mind so that we don't mix up the variables whenever we're trying to implement a queue. All right, so let it be there. Now, what we're going to do is we're going to have initial values. Now, these are going to be act like pointers, okay? So you don't want them to act like not a pointer value, so we do need them to act like pointers and only come up whenever they're being used or whenever a value is being inserted onto the queue. Okay, you don't want them to be pointing to something that is non-existent. All right, that's why we used like front is equal to -1 and rear is equal to -1. So basically, we're doing an array implementation, and let's say you're trying to, initialize them with these values, and this is something probably not really appreciated to do that, because we do want these to be pointing to their positions only when something is being inserted or only when they're being deleted. So I hope you understand why do we do this. And yeah, so we do initialize them with -1, as you can see over here. And now what we're going to do over here is this actually indicates that queue is empty. So as I already mentioned, you can have a picture in your mind that if you want to check if your list or queue is empty, you simply need to only check these two things to be making sure that the list is empty. Okay, all right. First, let's start with our insertion logic. Okay, we're going to start with the insertion logic, and when I talk about insertion logic, it's going to only affect the rear, but the front as well. I'm going to show you how. So right now, we're going to do rear, okay? And this enqueue is going to be for insertion. So let's talk about inserting our first element. All right. So we're going to insert our first element. Okay. I'm so sorry. Yeah. So we're going to insert our first element. Now imagine you got an array, and you're going to insert your first element onto your array. Okay. Now this is an array, and let me start by inserting my first element. Now this is what a queue probably represent, but if you're like on a queue, this is how we will represent it. But this is how it would probably stored, right? So 10. For simplicity, we'll have this as for now, so we don't really confuse ourselves. So let's say we got to insert our first element onto our array or onto our queue, which is 10. So also remember we are inserting an array, so this concept is purely on array. We'll also see other implementations like linked list and circular queues. So yeah, for now, let's just look onto this one. So first, we have inserted our first element. Now, what do you expect these pointers to do? Okay, what do you expect these pointers to do? The front should be pointing towards the first one, as we saw already in our queue example, where we have a queue and the first would be pointing towards this. So this is a front, and the last would be rear, right? So this is what we want here too. So this would be the front, this would be the front, and yeah, and the rear too. So rear is also going to be over here. Okay. But when you start inserting more elements, we don't want the front to move out, because unless you delete the elements, we don't want the front to move out. So only the rear is going to move from here onwards. So let's say we're starting to, put on more elements. Let's say 20. Our rear would no longer be pointing here. Our rear would be pointing here. All right. And let's say we're going to add 30. Our rear is no longer going to be pointing here. It's going to point over here. And do remember, arrays have size limits, and we'll talk about that later. For now, this is the concept. Okay. And we'll be also using, for indexes, we'll be using rear. Okay. So you increment it, and then to that position, you add the element. Increment your rear, and towards that position, add the element. Okay. You don't move front, because front is for deletion. Okay. So yeah, so let's talk about DQ as well. So DQ is going to be removal. So over here, we're going to start removing the element. So let's get started. So a front would be here. So when we remove this, our front will no longer be pointing here. It will start pointing towards this one. Okay, front. Because currently now this 20 is the first element. And then after you remove this element as well, our front would be pointing towards this one. All right, our front would be pointing here. And now let's just remove that as well. And now we got front and rear to be pointing to the same position. And think about this. Now 40 is gone, and 40 is also gone. And what I'm trying to do here is I'm trying to move the front. Now when front becomes more than rear, you can probably note that the queue is empty. All right, we don't have the queue anymore. Okay, so this is one of the conditions that you can actually put on your logic. Okay, so now let's start the logic, and I'll show you everything one by one. All right, so let's start with our queue logics, and let's get started. So you do need to remember that there is going to be a size for our array. Now we're going to have a class, and I'm going to have a queue. All right. Now inside this queue, we're going to have an integer array, and we're going to have front, and we're going to have a rear, and we're going to have something called as the capacity, and now we're going to have a constructor over here. Now the reason we have a capacity over here is this will take care of us so that we don't exceed the size that we have put our array on. Now you can create an array with a size 5 and just have 3 elements in it. So that would cause a lot of problems for you to track your capacity, because sometimes this capacity is really, really important. This variable is the one that helps you to find out whether you've reached the, whether you're going beyond your rear point or whether you're going beyond something like a certain limit, whether your queue is empty. So these are the things that would determine it. So you do need to have like a capacity, like the same thing that you had for a stack. All right. And now what we're going to do is we're going to have a constructor for this, and this constructor is going to be Q, and it's going to have a it's very simple. I'm just going to have the size. Now this size is what's going to be initialized for your capacity as well as your array. So we're going to have array capacity is equal to size, and then we're going to have an array, and this array is going to have new, and I'm going to have my size, and we're going to be initializing our front and rear. As we already mentioned, front is -1 and rear is also -1. And then what we're going to have over here is we're going to first do these functions. The first function would be checking if our queue is empty. So we'll be having a boolean function for this. So it's going to be boolean function is empty. So as I already mentioned, that if it is empty, we wouldn't have any values in it. So that would be means our front is actually at -1. So you can simply return front is equal to -1, or we're gonna have another one which is public boolean is full. Now for queue to be full, that means there is no space over there. You can simply use just your rear to check it. As we use front for empty, you can simply use your rear to check it. So I'm going to put rear is equal to the capacity. Now you can't really like use your full capacity because your arrays indexing starts from 0, 1, 2, and 3. So you have to put -1, and this would be your function to check if your queue is empty or full, which we would be using to check. Now for NQ and DQ, for NQ you need to check if your queue is full, because if your queue is full you can't further insert your elements, so you need to check. So we're going to be using is full for that, and for the DQ operation we would be using empty, because in an empty queue you cannot delete elements. So let's go and implement those as well. So we're going to be doing public void, and we're going to do an queue. Now here for enqueue, if you're doing an enqueue operation, you would be inserting a data. So we need the data for it. So that's why you need to pass in a number that you want to insert. Okay. But before inserting, as I already mentioned, we need to check if the queue is full or not. So I'm going to call just the function to check it. Now, if you return true or false, whatever, depending on the answer, if it is true, then I print a message for the user stating queue is full. All right. Okay. All right. So this is for enqueue. All right. And what we're going to do another one is see, you can use a condition, or you can simply use a variable as well for the next condition that we're going to run. Now, if it is full, you print queue is full, okay, and you just return it, so it won't continue further. Now, when you want to see, I already mentioned in our when you're visualizing, whenever we are inserting an element, we need to point the front towards it. So you can actually use two things. One is you can set your front, if you can check if your front is -1, you can set your front to be 0. That means you can make it point towards the first starting of your array, or else you can check if your queue is still empty. So that also resembles your same condition. Like you can see over here that if front is equal to -1, is it empty? So you can use both. You can also use a function for that. The next thing is going to be about insertion. As we already talked about, insertion happens at rear. So we're going to increment rear, and we're going to assign values to that area. Okay. So array of rear is going to have the value of x. Okay. So for example, let's say rear is -1. After we insert an element, it would become 1. And I'm so sorry, it would become 0 because -1 plus plus is actually 0. So at array of 0, you would be inserting your first element, that is x, might be a 10 or whatever. So this is what's going to happen until your queue is full. You can insert your values. Next function that we're going to do is a dequeue. A dequeue is a removal function. So we're going to write, as you already remember in our stack video, whenever we remove the element, we do return the element which we removed. So this function is going to be the same as well. Public int, and we're going to do a dequeue function. And for dequeue, there isn't anything you can pass into it, because for dequeues, you really remove the element wherever the rear is pointing towards. And for this, we're going to use an isEmpty function. And if it is empty, you cannot print anything. Queue is empty, and we just return, right? And now what you need to do for dequeue is you need to remove elements, right? So how do you remove elements? It's very simple. Remove is equal to array of front and front plus plus. So basically it will still stay in the memory. Okay, this is a very important point. I already mentioned in my stack video as well. Whenever we try to delete an element, we don't actually remove that element. Instead, we just move the pointer that's pointing towards it. For example, let's have an array. Let's have it like 10, 20, and 30. And this is where the front is pointing towards. And this is where the rear is, right? So now front is in the 0th position. Now what I do is I'm going to remove this element. So I store this element in a variable called as removed, and I move this front forward, making sure that it is pointing towards this element. So when the front is done plus plus, it is pointing towards the 20th element rather than being on 10, but 10 is still on the memory. Okay. And what you're going to do in the next one is very important. Once your queue is empty, let's say that you deleted all your elements. Okay, let's say you deleted all your elements. When you're deleting your elements, front would be surpassing 30. Okay, why? Let me show you. So you can see that these are the elements 10, 20, and 30. So when you delete the 10, front would become 1, and when you delete 20, front would become 2, 30, and then front plus plus will happen. When front plus plus happen, it will become 3, which will surpass the rear value, which is still didn't move, and it's still pointing towards 2, the last element. Okay, So let me visually show you. So at first, our front is going to be at -1 and rear is going to be at -1. Let's start inserting elements. So at first, we insert 10, and over here, front as well as rear both point towards it. When I insert 20, rear starts pointing towards 20. And also remember that after you move your rear, you insert your value. So move your rear and then you insert your value. This is how you do. You move your rear pointer over here and then you insert the value over there. So rear is pointing towards this one and front is pointing towards this one. So right now front value is 0 and rear value is actually 2. When you're deleting, that is complete opposite. So when you're deleting, you basically move your front. Before moving, you just store this element in a variable you store somewhere so that you can return this value. And then what you do, you completely move your front over here, and the front would be 1, and your rear would be still 2. You won't touch the rear, then you're deleting. Now your front would move here, which is front is equal to 2. And now what you do, I missed the step. You store this and then move your front variable. And when you move your front variable that's pointing towards 30, now what you do, you remove these completely and forward this. But before forwarding, you store it and return it, and then you move your front. So your front would be 3 now, and the rear would be 2. So whenever you remove all of your elements from the queue, you actually do this. Your front surpasses your rear, so that is going to be your next condition. If my front is greater than rear, then my queue has become empty. Now remember, whenever you empty your queue, make sure you do front is equal to -1 and rear is equal to -1. Why are you doing it? Because right now your queue is empty. Don't ever make your pointers to point something that is non-existent. Make sure you do your front -1 and rear -1. Okay, this one you have to do it. All right. Now what I'm going to do, I'm going to return the removed element. So return whatever is being removed, return it. If you are not doing this front equal to -1 or rear is equal to -1, then when you're again trying to enter elements or delete your elements, when you're trying to delete elements, it will access this array of front, and when it is accessing it, it will say array index out of bounds. That is why you need to also think about these conditions as well while you are putting it. Now there are other functions called as peek. Now peek means it will allow you to see the top of the element or the first element in your queue. So peek is very simple to implement. So let's go and let's see how to implement peek. So peek is public int peek, and to do peek, first you would check whether your queue is empty or not, because you don't want to be accessing uh, a variable. So if it is, so we can only return an int variable. So I'm going to do -1. Now if it is not empty, then you can return your front value. Now after this peek, we will have a display option where we will display our queue. And displaying also, you need to make sure that you have values on your queue. To do this first, let's go ahead and let's do if is empty. we will print q is empty. Sorry, q is empty. And after this, we need to make sure we are actually returning. And now what you want to do, you're going to do for int I is equal to front, less than equal to rear. And this is how you print it, okay? Don't print like from the 0th element to your size of your array. Don't do that, okay? Print your element. Array of I. You can also print it on the same line. I'm just printing it in the next line. Yeah.